Section 12.1, Example 2, letter B. Directions again, we want to estimate each one-sided or two-sided limit if it exists. As I take a look at our limit here, x is approaching 1. There is no plus or minus up where that exponent normally would be, so this is going to be a two-sided limit. We will need to calculate the left-hand limit, the right-hand limit, and then determine if the overall limit exists, this limit right here. I'm going to make our xy table. I'm going to make 7 x values and corresponding y values. One is where we are evaluating our limit. I'm going to put that in this middle box here. And then again, add and subtract 0.001, 0.01, and 0.1 to get the other x values. From here, we'll plug our values into the calculator. Again, I don't need to calculate this y value. That does not help us determine what is happening with the limit. The limit is determined only by the values that get close to that center number. Going into y equals, typing in our equation. In parentheses on the top, I have 2 minus the square root of x. On the bottom, we have an x plus 3. Again, on this older operating system, that fraction is written out horizontally, so I'm going to use parentheses around the top and the bottom. I'm going to go in and type over the top of some old values and get all 6 of my x values for my table. So there are my 6 x values and corresponding y values. Now let's copy those into the table. Rounding these off to 4 decimal places when necessary. When we take the test, I will give you our equation and I will give you the x values already filled in. You'll just need to type in the equation and the corresponding x's and then write the y values in on our table. If it is a two-sided limit, I will have both sides, the left and the right side notation written in for you. It would look like this for this problem. Over here on the left, we have the limit as x approaches 1, but these are from the numbers that are a little smaller, so I give that left-hand limit notation. We can either put f of x equals, or you can use the original. So I would have this written right on the test for you. Same thing with our right-hand limit. This time x is approaching 1 from the numbers that are a little bit bigger, so we'll have a plus here. And again, in this spot, you can either have f of x equals, or if you want, you can copy down the original. I'll have a blank here and here after the equal sign for you to fill those in. And then you'd want to compare these two and come up with an answer for the overall limit. So if that's a test question, that's what it would look like. Again, You'd have the original problem. I would give you the x values. You would need to plug into your calculator and calculate the y values, and then I would give you these three limits listed out exactly the way that they are here, with a blank after each equal sign. For our left-hand limit, we're looking at the limit as x approaches 1 from the left side. So as our x's get very, very close to 1, you'd want to be taking a look at these y values and making a prediction about where you think they are headed. As I look at these y values, we have 0.2696, 0.2519, 0.2501. Looks like those are getting pretty close to 0.25 for the left-hand limit. Do the same thing with our right-hand limit. As our x's get close to an x coordinate of 1, we want to take a look at these three y values we have here. And as we go from right to left, as we go towards the middle, we want to see what number those x or those y values are getting close to. 0.232, 0.2481, 0.2499. Looks like these are getting very close to 0.25. So my best estimate, again, these are estimated values. Directions say we're supposed to estimate these. We don't know what they are. We're not calculating them exactly. We're just looking at a table to try to estimate what these y values are going to be, what these limits are going to be. Our best estimate for this left-hand limit is 0.25. The right-hand limit is 0.25. If these numbers are exactly the same, or if they're very close to each other, again, these are estimates, so they could be off a little bit. If they're exactly the same, or if they're very close to each other, then the overall limit exists, and it would be equal to those numbers. So the final answer would be that the two-sided limit exists, and it is approximately equal to 0.25.